Hello my dears. So now we are going to discuss about steady state stability. So by using the swing equation we can analyze the steady state stability. So I already told you that what do you mean by the steady state limit or steady state stability. The concept of steady state stability is nothing but, my dear, a small disturbance. Now if you give a small disturbance given to the system, and due to that disturbance for small fraction of time the system is vibrating or the system is oscillating, and after that it will come back to the original position. So that is called the steady state stability. So small disturbance, what happen when we are the system is subjected to a small disturbance is called the steady state stability or steady state concept. So consider a single generator. I mean, for the analysis purpose now it will be very easy then. So this is the B angle 0, that is a receiving voltage, this is a transmission line, and this will be E angle del. This will be E angle del. So consider a single machine right here. Consider a single machine, okay. Closed circuit you can make like this. So consider a single machine which is delivering a power to the this is the infinity bus bar. You can assume like V angle 0, because ideally the voltage is taken as the reference vector. So normally V will be referred as V angle 0 is the terminal voltage, okay, under no load condition. And E angle delta is the induced EMF. Why the angle delta means definitely the rotor will be at a certain rotor angle. So the induced EMF will be represented like E angle delta format. Okay, that's all. So so what will be the electrical power, my dears? What is the electrical power output? We already discussed in the power system. I mean the basics of power system, that P is nothing but, my dear, EV divided by X into sin delta, where delta is nothing but the load angle. Okay, initial load, it will be initial delta 0 na? So initial load angle. So where delta 0 is nothing but initial load angle. Is it clear, my dear? So what happened when we are subjecting a small disturbance to the rotor angle? So let be delta del. Okay, that means initially the rotor angle is delta 0. What we are doing, if a small disturbance is given to the rotor angle, that means the angle is nothing but delta. Okay, delta del. Any way you can assume like a small disturbance is the meaning is as, suppose the rotor angle is 5 degree. You imagine like 5 degree. Then you simply decrease 6 degree. That's all. That is the meaning of a small disturbance, or 5.5 degree or 6.5 degree maximum. Not up to 10-20 degree increased. Not the meaning of that will be a transient state. I mean transient stability, that will be. So steady state stability analysis means, a steady state means what? A small disturbance is given to the system and we are analyzing the system, what will happen to the stability. That is the meaning of steady state stability of the system. So what happened? The initial load angle is del 0, and if you are increasing the angle by a small value, that is del. So what will be the power equation? This power equation also can be written like, see my dear, this will be P max into sin del 0. That also you can write P is equal to P max, where P max is nothing but EV divided by XS. Okay, so what will be the new power? The new power will be nothing but, my dear, P is equal to, I can say like P is equal to P max into sin of del 0 plus delta del. Is it correct? Is it correct? So it can be elaborated like, P max into, what is sin A plus B? It is nothing but, my dear, sin A cos B plus cos A sin B. Right? So this will be the expression, I mean expanded expression for what? Now our sine delta plus delta 0. So we have by mathematical or trigonometry, for small values of, for small angles I can say that sine of del delta is nearly equal to del delta and cos of del delta nearly equal to 1. We know that for this is a trigonometric identity or angle identity that for small values of sine theta will be nearly equal to theta, and for small values of theta cos theta will be equal to 1. Okay, is it clear? So I can substitute there the value like what happened then. P is equal to, my dear, listen, P is equal to P max into P is equal to P max into sine delta 0 can be represented like sine delta 0, that nothing, no change in that. Sine delta 0 cos delta is can be represented like 1 plus cos delta 0 can be represented like simply cos delta 0, no? Cos delta 0, sine delta can be represented simply del. Is it clear? Is it clear, my dears? So sine delta 0 into cos delta 0 into del. So if you expand it, it will be like P max into sine delta 0 plus P max into cos delta 0 into del. Okay, that will be the P. That will be P. So what is this P max into sine delta 0, my dear? So let be P is 0. Let be P is 0, initial value. Okay, let be P is 0. So I can say that P is equal to P is 0 because for delta 0 the initial electrical power output will be P is 0, that's all. So P is 0 plus P max cos delta 0 into del. Okay, is it clear, my dear? And see, it can be again write like P is equal to P0 plus what is P max cos del 0? I can write it like dou P divided by dou delta del is equal to del 0 into del. Am I right, my dear? See, we have basic equation for P is nothing but P max into sine del 0. Okay, so initial value of you can take like, so if you see, this is nothing but dou P is 0, correct? It is nothing but, my dear, what will be the derivative of this function? This is P0 now. P0 will be P max into sine del 0. That is the initial value of power. What will be dou P divided by dou del? It will be P max into cos del 0. Cos del 0 now. So generally, my dear, I can say that if P is equal to P max into sine del 0, then dou P divided by dou del at del is equal to del 0 will be equal to P max into cos del 0. Am I right? So this can be directly write like dou P divided by dou del at del is equal to del 0 into what? This identity can be applied here. If P is equal to P max into sine del 0, then dou P divided by dou del at del is equal to del 0 will be P max into cos del 0. Is it correct? So this will be the final equation. So from this equation, my dear, this will be the final equation. P is equal to P0. This is the important relationship. So P is equal to P0 plus dou P divided by dou del into del at del is equal to del 0 into delta. Is it clear? So this can be right like P is nothing but, my dear, new power, and this is nothing but initial power, and plus this will be a constant, and this is in radian. this angle is always in radian. So you should take care of this parameter. This del is always in radian. So this is the what resultant power equation for what, my dear? In the case of a steady state limit. Okay, steady state stability. In the case of a steady state limit, this equation is very, very important. Okay, we will expand it further. Okay, we will expand it further. This is actually an analysis, my dear. That's why you may feel slight difficulty, or you may feel like boring. Okay, don't worry. We have to study anyway. Nah? We have to study anyhow. So we should do this also. Then only our syllabus will be completed. Without that, there is nothing. So see, I will take it like this. Okay, my dear. So we have what? Listen. So we have what is get finally P is equal to P0, right? P0 plus dou P divided by dou del at del is equal to del 0 into del, right? Which is the final equation. Listen, my dear. Okay, let be equation number 1. You assume like what will be the swing equation? M into d square del by dt square, right? M into d square del by dt square equal to Pm minus P. Am I right, my dear? This is the basic swing equation. What is the need? The steady state stability can be done with the swing equation. I already told you now. So I have to call the swing equation. So M into d square del by dt square equal to Pm minus P is the swing equation. See, my dear, what is P now? You got it now. The P value you got it now, na? So it can be substitute like, which is equal to Pm minus of P is nothing but P0 plus dou P divided by dou del at del is equal to del 0 into del. Am I right, my dear? So what happened? These and these got cancelled because under initial condition, whatever you give the mechanical energy to the system, so this is the alternator, the same will be converted into the electrical energy unless the losses are not considered, right? If you neglect the losses, we already deal with the assumption is that we don't consider the losses. That means whatever the mechanical input you given to the alternator, the whole will be converted into the electrical energy. So this Pm is nothing but the mechanical energy. P is nothing but the electrical. P is nothing but the initial electrical energy. Na? So initially Pm minus P is the correct equation. So Pm minus P you substitute for that. P is initial electrical energy. That is nothing but the initial mechanical energy. So initial mechanical and initial electrical energy will be equal. That means whole will be converted. So the rest will be nothing but, my dear, M into d square del divided by dt square equal to, or simply equal to minus dou P divided by dou del at del is equal to del 0 into del. Okay, so or I can write like M into d square del by dt square plus dou P divided by dou del is equal to del 0 into del equal to 0. Del is equal to 0. Okay. Also we have del is equal to del 0 plus delta del. Then what will be d del divided by dt? What will be d del divided by dt, my dear? It will be d del means a constant, so it will become 0. So simply d del divided by d delta del divided by dt. Then what will be d square del divided by dt square, which is nothing but, my dear, d square delta del divided by dt square. Okay, is it clear? So it can be applied here. Okay, it will be equation number 2 and it will be equation number 3. Substitute 3 in 2. Substitute 3 in 2, you will have m into d square del delta na, symbol of delta convert what means replace it with del delta divided by dt square plus dou p divided by dou del at del is equal to del 0 into del equal to 0. So this will be the final equation, right? This will be the final equation. Let be equation number 4. This is the final equation. Okay, this is very important relationship. So m into d square del divided by dt square plus dou p divided by dou delta at del is equal to del 0 plus a into del delta is equal to 0. So listen my dear. Okay, you noted that. So I am going to replace it. Okay, just listen. So this can be written like if you divide the whole term with the m, then what will be? So before that, m into t square del divided by dt square plus k. I represent this term as k. Okay, k into del equal to 0. Divide with the m, d square del divided by dt square plus k by m into del equal to 0. So this will be in the form of, my dear, differential equation, second order differential equation in the form of d square plus k by m into del equal to 0, or in other words d square equal to minus k by m, or simply d is equal to plus or minus root of minus k by m. D is equal to plus or minus root of minus k by m. Okay, is it clear, my dear? Okay. Steady state stability is a topic in your syllabus. If you check the syllabus of electrical inspectorate, it is there. Steady state and transition stability, both are there, right? Stability analysis is there. So never skip this. So D will be, finally you got it like plus or minus root of k by m. Then case 1. Case 1. K less than 0. K less than 0 means the value of D will be plus or minus root of simply k by m minus. If k less than 0, substitute k any negative value, then inside the root will be positive quantity. So I can say that the roots are real and real. Roots will be real and equal. Real and equal. Am I right, my dear? If k is negative means, k less than 0 means the roots are real and equal. Magnitude will be equal. That's the meaning. Real and equal. So what will be the resultant value? That means resultant, we have to solve it for what? We have to solve for del. Na? So del will be equal to what, my dear? Del will be equal to C1 into e raised to root of k by m into t plus C2 into e raised to root of minus k by m into t. Is it clear? This is actually, we already discussed in the differential equation analysis. No? Mathematically, in mathematics, if the roots are real and equal, then definitely the solution will be C1 into e raised to the real root into t minus that same into t. That will be the what? That will be the resultant del. So if you plot the graph between, this is time against del. If you plot the graph between time against del, definitely if you are going to plot means the analysis will be after t is equal to 0. Of course, for t less than 0, this is for t less than 0 quantity. Na? I mean, it is exponentially decreasing. 0 less than b, this will be like this, this will be like this. But our analysis will be always start from c, t greater than 0. T greater than 0 will be only our analysis will be. That means if you are disturbing the daughter means at that time itself the time starts. So t greater than 0 will be only we have to consider. So the things will be nothing but only this term will be exist for t greater than 0. So it will be an exponentially increasing system. That means c1 e raised to something into t means it's an exponentially increasing signal. So this will be the output of the system, and finally we found that this is an unbounded signal. So finally this signal is unstable. So my dear, the final result, the beautiful result we obtained is nothing but if the value of k, that is nothing but k is nothing but what, dou pe divided by dou del at del is equal to del 0. If you obtained that value as negative, definitely you can say that system is unstable, that our power system will be unstable. It will not come back to the stable position if k is less than 0. If k is less than 0. Okay, is it clear, my dear? Then what happened if k is greater than 0? If k is greater than 0, what happened? Case 2, we will discuss case 2. Case 2. K greater than 0. Then what will be the value of d, my dears? D is equal to plus or minus root of minus k by m. So it will be like this, plus or minus j root of k by m. Then what will be the solution if it contains plus or minus j, that means imaginary term? The resultant will be nothing but, my dear, del is equal to c1 into cos of root of k by m into t plus c2 into sin of excuse me, okay, sorry, I had a small sound, my dear, that's why I checked. So del is equal to nothing but the solution will be c1 into cos root of k by m into t plus c2 into sin root of k by m into t. That means it contains a sinusoidal plus cosine function. Means if you plot a graph between time against del, this will be the function. This will be the function. This is bounded. It's a bounded signal, na? Hence it is stable also. Okay, and this is without damping. Is it clear? And if you are using damping to damp out the oscillation, okay, if you are using damping, then the system will be having produced some output like, finally it settles down. This is also bounded, this is also stable, and this is with damp. Is it clear, minus? Note these points very carefully. Okay, is it clear? So what happened when k is equal to 0? The system is stable. The gives system stable. When k less than 0, the system will be unstable. That's all. The system will be unstable. Is it clear, my dear? Is it clear? I know this is actually very difficult to digest. I know that, but refer 2-3 times. Read it carefully. Derive it in your notebook. Na? take a sample rough page or derive 2-3 times. Okay, it will be in your mind. See, question will be asked from any portion. What happened when k greater than 0? What happened when k less than 0? Anything you may ask. So you have to answer everything. So that's why I'm telling all this. Okay. So next is frequency of oscillation. I already told you this will be the oscillation producer, right? Oscillation producer for k greater than 0. Then what will be the frequency of oscillation? Frequency of oscillation. The same thing you already learned in control system also, my dears, because whenever the roots are j, which will be in the imaginary axis, then definitely there will be oscillation will happen. The same thing in different way, in different manner, in different explanation in the power system also. That's why I already told you that when you deeply learn something, you can connect every subject, I mean, like one. No circuit theory, no machines, no power system separately. You can conclude it as a one solved, right? So listen. So frequency of oscillation, my dear. So from this will be in the form of C1 cos omega into t plus C2 sin omega into C. Then what will be omega, my dear? What will be omega? Omega is nothing but, my dear, root of k by m. Root of k by m. Then what is k? K is nothing but, my dear, dou p divided by dou del at del is equal to del 0 divided by m. Or simply, it's nothing but, my dear, dou p divided by dou del at del is equal to del 0 whole divided by, that is m, gh divided by pi f in the case of radian, gh divided by 180 f in the case of degree, gh simply h divided by pi f in the case of per unit. That's all. So that is nothing but the omega. If you know the omega value, omega, that is a oscillation, then you can find simply frequency, because omega equal to 2 pi f. Simply 1 by 2 pi will be the frequency also. I will write that also. Then the frequency of oscillation in terms of hertz will be nothing but 1 by 2 pi root of this much, dou p divided by dou del at del is equal to del 0 into pi f whole divided by gh in radian per second. Frequency of oscillation will be simply hertz. So this will be radian per second. Radian per second. Okay. Is it clear, minus, my dear? So this is also very, very important. These two relationship also very, very important. Okay. This is, you have to take care of that equations also, you have to take care. Rest this derivation and that's not that much important. This is for your analysis. Okay. For your knowledge, I derived everything. The final equation you have to remember all the time. Okay. The value of k, the value of the frequency, direct question you may expect by simply substituting these things in examination. Direct question you can expect. Actually, these are very deep power system analysis. They are very deep power system analysis. Normally, in normal competitive examination, in electrical inspectorate examination also, this regarding this stability, I think no question were asked, right, regarding stability. So rest of the things will be asked in power system, no, not stability, because stability is that much deep subject. I mean, deep topic it is. It is very difficult to digest and very difficult to understand. So please, 2-3 times you have to read it. Definitely you will get some idea. If you have any doubt, please mention in the comment section. Okay. If I know, I will answer it. Okay. Otherwise, I will search and I will find answer. Okay. Thank you so much.